This video will show you how to do problem number 3 of energy conservation with a rubber band. I've set it up to where I give you the information to where we can actually ignore the kinetic energy. So I use a rubber band to launch 0.6 kilogram marble straight up in the air. And the marble is going to go 0.7 meters above the release point. So it's important to understand what the picture is over here. So I have it stretched. So when my marble is down here, I have some potential energy of the spring. I let it go. I now have changed the potential. Now I have a potential energy of gravity. The spring, all of this energy is going to go into moving the marble from here to here, and that distance is 0.7 meters. So I'm going to take my potential of the energy of the spring is going to turn into potential gravitational energy. So we can find, I need the spring coefficient, so that means I need that before I can find the potential energy of the spring. Now if you want to, in the notebook, I just plug the formulas in and plug the numbers in. But we could just find what is my potential energy going to be, assuming that my UG is 0 at the beginning. Then it's just going to be M, the mass, times G times H. So the mass is 0.6. Times G is 10, times H, I went 0.7. So that's just going to be 6 times 0.7, which should be 4.2. If I can do stuff in my head, there we go. So my new potential energy is 4.2. Where did that come from? It all came from the spring. And my potential energy of the spring is 1/2. That's my formula, K delta X squared. So that means 4.2 equals 1/2. The K is what I'm looking for, and my delta X, I stretched it 0.4, is 0.4 squared. And if you solve for that, you get 2 times the 4.2 divided by 0.4 squared, 52.5. Now if you wanted, you could actually solve for the kinetic energy that you got, find out what that was, and then use that to find the spring constant. But this is a simpler way to do it in this problem.